John Dalton was an English school teacher, yet he studied gases. John Dalton believed that all matter is made up of individual particles called atoms that cannot be divided. John Dalton's main focuses were that all elements are composed of atoms, and all atoms of the same element have the same mass, and all atoms of different elements have different masses. He also said that elements composed of more than one atom are called compounds, and that atoms of the same element are always combined in the same way. Dalton's theory also included pictures of solid spheres. He said that each solid sphere represents an atom and they all have different masses. Many people widely accepted Dalton's theory. Over time, scientists found out that all ideas Dalton thought were not correct. J.J. Thomson was another English scientist. J.J. Thomson revised Dalton's atomic theory. J.J. Thomson said that the atom could be divided. He discovered the negatively charged part of the atom, called the electron. He used a cathode ray tube. When voltage was applied, it created a path of electrons. Thomson found that electrons will always move to the positive charge. Thomson revised the theory, calling it the plum pudding model. The plum pudding model showed electrons floating around in positively charged matter. Ernest Rutherford added more to the atomic theory. He shot alpha particles at a very thin sheet of gold foil. Some particles scattered and some bounced back. He discovered the positively charged particle called the proton. Ernest Rutherford and his colleagues came to the conclusion that the nucleus was positively charged, and that electrons move freely around the nucleus. He also said that the atom is mostly made up of empty space. Niels Bohr created the modern view of the atom. He was a professor of physiology. Niels Bohr agreed with Rutherford's model of a nucleus surrounded by a large volume of space. Bohr's model showed that electrons orbit around the nucleus. He also said that electrons could move up another energy level if given enough energy. Bohr also said that electrons can only exist on energy levels, not between them. Louis de Broglie said that particles can act like waves and waves can act like particles. He was a French physicist. He said that electrons are better described as waves, not particles. This was great news to scientists because they could look at the wavelengths instead of measuring its velocity and mass. Erwin Schrödinger discovered the mathematical equation to show where electrons, he was a professor of chemistry, are located around the nucleus. He said that electrons shouldn't be pinpointed down like the Bohr model, and it is called the electron cloud model. James Chadwick discovered the particles with no charge called neutrons. We now know the neutron is located in the nucleus.